Hello, welcome to everyone to this webinar that has been organized as part of a series of webinars from the SusFE project. SusFE project is an Horizon Europe project funded by the European Commission, and our aim with this project is to combine materials and processes to offer eco-friendly solutions for wound healing, self-blood sampling, point-of-care devices, and also cardiometabolic sensing. This project is coordinated by Medtronic from Spain, in this case, Medtronic Ibérica. Within our capabilities in Medtronic Ibérica, we have a project management office where we support different teams, R&D teams from our global company to participate and to develop innovative ideas in the healthcare field. With me, we have Pilar, also from the Innova team, and also Yves from France, who is a scientist working on the surgical innovations area. Yves will chair the session today for all of us. So Yves, the floor is yours.
Thank you. So good afternoon or good morning or good evening, wherever you are. So I'm very pleased to have, three remarkable speakers today and to speak about, electronics printed on paper, which is a new way to consider electronics to be integrated in wearables and any other electronic goods. They will speak about, challenges, key achievements. We have the voice of two RTOs, two European RTOs, Valerio Beni from Sweden, Daniela Collin from Germany. And we have also a commercial perspective of electronics printed on paper from Alan, based in Taiwan. So they will have a 15-minute lecture. With the different perspectives, starting from the research and development work, and also Alan from R&D plus commercial marketing communication activities related on this topic. Question can be raised at any time by using the chat, and please do it live. And the ladies from Medtronic will take a look at it, and then we will start from the question mentioned put in the chat box. All speakers will introduce themselves very rapidly to take most of the time for the lecture. So please, Valerio, you are the first one. Introduce yourself rapidly. Introduce as well your Horizon project, part of the same call of project of SusFE. And this project is, and this webinar is on the behalf of SusFE, but also the Green Electronics Working Group, gathering all consortia coming into the same European project call. Valerio, the floor is yours.
Thank you. Can you see my presentation?
Not yet, but I guess it's
try to go
yes,
now.
It is. Go ahead.
Yeah,
and
perfect.
Use the full screen mode, and this will be more
Should
than
be
perfect.
Is it now in full screen? Or you see presenter
yes,
mode?
now.
Yeah, perfect. So good afternoon or good evening. My name is Valerio Beni. I'm a senior scientist project manager at RISE Research Institute of Sweden. We'll give you 2 lines about RISE in a moment. And I am the coordinator of one of the European projects that Yves was mentioning. It's called Hyperlinium. Nothing to do with paper. It's printed electronics on wood. But I am one of the initiator of the Green Electronics Working Groups. One of my colleagues at EMPA was actually leading and starting this one. Let's go in directly into the presentation. And I would like to present you something on hybrid print electronics or print electronics on paper, some challenges, but also some opportunities or what you can do when you overcome the challenge. As I said, I am from RISE, Research Institute of Sweden. It's relatively new research institutes, gathering several research institutes previously present in Sweden. We have more than 35 locations, but what is very interesting and what is quite important for us, we have around 130 test beds where companies can access technology. And I'm coming from one of them. It's called the Printed Electronics Arena, or PIA. It's a reference laboratory for printed electronics where we offer facilities and service, and we do research in terms of material process for the printing of electronics. And we mainly look into 2D printing, so and we look at on flat surface, looking at screen printing, inkjet printing, but also we look at hybrid print electronics. So we also look at ways of integrating silicon components onto our printed structures. Why we are interested in paper, or why we have been interested in paper? Actually, I think the first project was in beginning of 2000. So we are interested because we want to try to give a little bit of a sustainability and resilience spin to the electronics, especially the Internet of Things and consumer electronics. And to do so, we could act in a variety of elements. We could look into materials, for example, inks. We can look at components, sensor, energy storage. But we also look at the substrate, so the PCB board where the printed electronics is actually performed. And in this presentation, I will look on paper as the substrate to do this. Why paper? Well, printing on paper is a long history. Paper and cellulose industry are actually very well established in Europe, and there is a need for, especially with a lot of media transfer of reading materials, there is a need to reshape a bit of it. Paper is also very well spread in our world, from logistic to construction to medtech to energy applications. And as I said, there is a lot of knowledge on paper and paper chemistry. So that could bring advantage to tune some of the properties. And of course, paper is a biogenic materials and is actually well-established material that could be recycled. So this could bring a significant benefit to create a sustainable value chain and a sustainable system. So paper, it seems relatively easy. As I said, we have been using paper and printed paper for quite some time, but it's not straightforward to work with paper. And I would like to highlight a few of the issues. Well, paper dimensions are not stable. The dimension of paper is very strongly dependent from its moisture content. It's something that is nothing new. But what is the challenge with paper is that its dimension actually change dynamically. So the release and uptake of water is actually continuously taking place. And that means that you cannot stabilize, as you do with some of the polymers, the dimension of the paper by simply having a heat treatment. And the dimension of paper, or the change in dimension of paper, also changed significantly with its composition. For example, paper made with a recycled fiber have the tendency to actually be more dimensionally stable. What I'm showing here to you are some of the results we obtained in try to analyze these properties. And what is very interesting is that dimension change, as I said, if you leave the paper after a curing step into conventional atmosphere, but the dimension change not only between papers, but also dimension change also with the direction of the paper. So depending on if it's the web direction during the production or not. How can you counteract this? Well, you can use, for example, curing methods that do not heat up the paper substrate. For example, in roll-to-roll, you could use some infrared that's allowed to cure the inks without heating up too much the paper. And but also you can use some sort of thermal treatment. So what we usually do when we work with paper, we tend to heat it up the papers before doing each consecutive print. Printing on paper and resolution on paper, it's not straightforward. This is common to also other substrates, not only to paper, but one of the challenges is that most of the material that we use, they are not actually used for or designed for paper. So most of the inks, they're not designed for paper. They are mostly designed for other substrate. And here you're just comparing two paper from, we're comparing two inks, and you can clearly see that they behave very differently. So choice of the inks and matching inks and paper is very important to obtain the desired resolution and performance. And how do you do this one? Well, one thing we do on a regular basis when we investigate different substrates, we do investigate line widths, line separation. We investigate how the orientation of the lines affect both dimensional and performance. And but also we also check how how the direction of this is mostly screen printing, how the direction of the squeegee affect the resolution. And that's just an example of an in-depth evaluation that one of my colleagues have been performing under the framework of the Sustronic project. Chemistry of cellulose is also known and not always help us. So in recent time, there have been growing interest, for example, on nanocellulose as a filler to provide, for example, smooth surface instead of more conventional inorganic fillers. But that's not that sometimes doesn't help. What you can see on your, I don't know if you can see my cursor. I think you can. Let me see the pointer.
No. Yes, we can see your pointer.
Yeah. So what you see here, you see exactly the two material combinations that they are exactly the same. So it's a paper substrate with some silver line printed on them, at which we apply a potential. But on the one I'm showing you, there is no red shadow, while in the other one you have a red shadow. And what is this red shadow? It's actually dendrite formation. It's actually migration of silver through the coating. What is the difference between the coating? It's the chemistry of it. One is a carboxymethylated nanocellulose, the other one is a sulfonated nanocellulose. So the choice of the materials and understanding and thinking about the chemistry can actually be very important for the success of the work. And paper surface property can actually strongly affect adhesion of the inks. Once more, paper and paper coating and paper modification has been mainly done for other applications, for anti-greasing, have been done for having a smooth finish and so on. But this doesn't mean that these properties actually are beneficial for printed electronics. In here, we are testing 3 different papers from the same family. So they are supposed to be relatively similar. But as you see, for example, paper 1 and paper 2 have a relatively poor adhesion or no adhesion actually with the silver in itself, but had a very good performance with the dielectric. So you could actually use a dielectric inks as an interposer to strengthen the adhesion of your printed lines. While paper 3 doesn't really like either the silver, either the dielectric. So there is a lot of things to consider. There is a lot of things to test when we want to introduce paper, especially if you're not on more exploratory project like we do. But when everything is set right, what can we do on paper? What you can actually manufacture? This is something on that we develop. Or we are looking into the so-called Digital Cellulose Center. Digital Cellulose Center is a national project. Now it's at this 7th year. So it's a center of excellence on cellulose and electronic on cellulose. Here you will recognize NFC antenna. That is something that will be presented more in depth in the next in the next presentation. But what is different from, or what is our take? It's we introduce also a vertical electrochromic display. If you want to understand the complexity of it, you see this is a kind of breakdown. So you have several layers that need to be printed in a sequential way, and all of them with relatively good alignment and relatively good resolution in order to be able, for example, to assemble the chip. So this is just a stack, schematic of the stack, and then you see you need several of these materials, and some of this material we actually have to be tuned in order to allow this architecture. Even more fun for us is to actually try to push even more the limits. In this case, we increase further the complexity, and we not only printed the electrochromic display. Interestingly, in this case, the electrochromic displays, it's printed on a transparent paper, so it's actually a very classical electrochromic display performance. But what we had to do, we decided to add some batteries. So that's when there is a moisture between the root, you will actually generate some power, and this power will lead to the switching of the electrochromic display. Just for us, a way of putting together several layers and demonstrate that we can, by tuning and by working on the paper and on the inks, we can actually make extremely complex systems. One of the aspects that one of the things could be done also with paper, we could take advantage of its flexibility and so on, and we could integrate in products, in variety of products. In this case, in Sustronic, one of my colleagues, he's looking into integrating a multi-sensorial elements, so into diapers for elderly care, And to do this one, this is done on paper, and this required the printing of several layers. So as I said, it's really required a good tuning of the materials. It requires a good tuning of the matching between paper and materials. It requires a very good tuning of the process. But if you do it right in the right way, you could actually even perform manufacturing of it on a roll-to-roll base, as you can see on the right here. So that's a roll-to-roll printed at one of our collaborators. It's Benelli. It's print electronics manufacturer here in Sweden. And then you can have actually these strips printed with several materials on a roll. So that's one of the most advanced things we are having at the moment. I would like to have another couple of slides if I have time. Paper is not
2 minutes.
Yeah, okay, perfect. So you don't really printing is actually very much a key for paper, but there are other technologies that could be used. For example, in this case, it's a technology from Armo EMAC that we are working together on basically on the laser transferring of aluminum, and then we did NFC antenna. We did NFC antenna with them, so that's RFID antenna. So that we can demonstrate that we can actually use that technology to make active materials, active functional device on paper. What is the next? This is just one slide on hybrid print electronics. So in my view, what's the next and what is important is we can more and more increase the complexity of paper. We don't need, not only by increasing the complexity of the material that we print and the geometries, but also integrating more and more functionalities. And this is, I like this view. When I started in 2014 at RISE, we developed a single-use point-of-care print electronic system. He has NFC communication, he has a display, and he has an electrochemical sensors. But to achieve this one, we needed three different chips, and we needed quite large energy storage. Now, the microelectronic companies are actually working towards more efficient and more integrated system. And in another European project called GreenSense that's ended in 2022, we developed together with Infineon a point-of-care system for measuring 6 parameters, but having only based on one chip. And moreover, being the chip start to be available on a bare die, or through collaboration, you can have a bare die chip. This actually simplify significantly the assembly, because you have more freedom than with a conventionally packaged system. Last slides, of course, we need to, I need to thank who helped me, the team, the people that worked on it. And these are the people that belongs to the two units on my side at Print Electronics, the Bio and Organic Electronics and the Print Electronics units. Our partnership, so our extended network, more specifically in this case, Green Sense project. It was a H2020 project. Digital Cellulose Center, that is a Vinova national funded project, and Sustronic, that is a ChipJU Horizon Europe project. And of course, we need to thank the sponsors, the European Union and Vinova for this funding. And of course, I need to thank you for taking the time to listen to me.
Thank you
And that's
so much.
what's it.
Yes, thank you. That was a very good talk. Don't hesitate to put question in the Q&R button. They are very welcome. And I guess you should ask question because it was a great introduction. Alan will come next with a commercial expertise of printed electronics on paper. Alan, it is your turn. Keep your camera on, introduce yourself rapidly, and then tell more about your company and what you have done so far.
Okay, I load my slide. It's okay? Slide is on, yeah?
Yes, go ahead.
Okay,
Thank
good.
you.
Yeah, okay, that's it's my pleasure and honor to share our printed electronic process to the audience, to this sustainable, flexible electronic community. My name is Alan. I found this company for RFID since 2002, and we start to print this electronic RFID since 2014. So I started in Germany, Stuttgart, about 6 years. So I learned a lot from this sustainable ideology from Europe. So when I have the chance in Taiwan, so I try to fulfill because I know the conventional RFID production from antenna is quite polluted, so it's chemical etching. So one day I think that maybe that is the right moment. We need to do something good if RFID really get great business success. Yeah. So okay, I start my presentation now. Okay, DOP, I call all technology direct on paper. So I want to share our experience, successful story with larger scale real-to-real mass production solution for RFID and NFC antenna. So actually, I should know Rice and Valerio earlier. So maybe we will our development will be quicker because Valerio in Valerio's presentation, I see a lot. He mentioned about the difficulties, and if we know Rice earlier, and maybe we can do all development more easier. Okay. SNS, smooth and sharp, and now we are smart and smarter. So we use only additive manufacturing solution for RFID antenna and beyond. So actually, just I introduced, we started a smart card business 2002, and since 2014-15, we start to print antenna. And luckily, after 2 years, we achieved the first prototype RFID antenna, and with the chip on paper. So that is an inlay. So we call it inlay antenna and chip. And 2022, still up to date, we are the only ISO certified biodegradable RFID antenna. Later, I will show you some document. And in 2022, we have a further development with a finished product, plastic-free contactless card. And in the same year, we have NFC biosensor test drive on same substrate. Later, I will show you. And last year, our paper car, we received the certification from Paper Recycling Institute. Yeah. So it means our RFID paper car, you can just put in the waste paper recycling bin and easy to recycle. Oh, okay, okay. And this is our development roadmap. So our capacity is from prototyping to mass production. And very important, we are production oriented product development. That's very important. If we try to prototype something, and it has to be produced with very reasonable cost. So what we are doing now, you can see we can put more component. So you can see this picture, we can light up to 7 LED and one RFID chip, and we can print more layer. So in this antenna is UHF and NFC dual interface chip. So there are 7 layers in this design, and we can print on different substrate. Paper is good, but some customer require more durable application for many years, and they try to use PET and more complicated design. This is a design from our American customer. They try to print ECG instead of plastic. Yeah. And then we try to make finer line and cap. Yeah. Okay. Okay. Over the year, this is our secret kitchen. Okay. So as you can see, we run row to row. We run row to row. Okay. For some prototyping, we still with sheet to sheet. So you can see, okay, here is the paper come in. We need to line check, row alignment. And first we have inject, okay, row to row, flight control. And then depends on the different electronic requirement, we have a gravure, flexor, or screen printing. And then come to curing. So, okay, we have NIR, we have hot oven and photonic, and on the last is AOI. So over the year, we are up to date. We almost 8 years for this product development. I think row-to-row printing electronic in many ways is more printing than electronics. Yeah, because everybody know or today all this mass production product is not designed for printing electronics. All this machine is designed for graphic printing. So I think this is a big challenge if we step into mass production, but the machine is actually not for printing electronics. So this is the challenge. And thanks very good technology from this photonic, because the problem is the speed in the ink curing and sinter time is a paradox. It's a contradict. So you need to very quick curing time, but you need to dry your paper very quickly to get a high output. But when you run very quickly, your ink cannot be cured properly. But low speed is good, but don't forget our substrate is paper. It's a low temperature substrate. So if you run too low, maybe the temperature will be too high. He will burn your paper. So I think photonic is a very good solution to help us to find the right parameter to fulfill this mass production. Okay, see, okay, you can see our product RFID and NFC label with paper. And you can see we have this certification for eco-friendly and all row to row and different antenna design. And you can see that is a jumbo row. Mass production, we make mass production since 2021. And up to date, proudly to say, encourage for everyone working in the printing electronic. We already deliver more than 45 million UHF antenna and 5.5 million HF NFC antenna already shipped and bonded with different RFID chip and in the field, and no complaint. People use just like each antenna or Y antenna. Yeah. And you can see this jumper roll. I show you this is our standard product. We print with a 50 micron paper. I think up to date, or 45 micron thickness. I think up to date we are the one we can print the very thin substrate. And this roll is about 2,000 meter, roll to roll. Yeah. And you can see this is a typical NFC design. You can count that is a three layer. So I think in previous presentation that is correct. Paper tissue, they will change. They will change. Okay. After cooling, after heating, they will change. So I think we spent almost 2 years to find the right parameter and right process to control. Yeah. And okay. Sorry. Okay. So very important is everything is roll to roll. It's roll to roll. Roll to roll is very important because after printing, if you need to put some chip on your product, okay, boundary machine, most of boundary percent for mass production is roll to roll. Okay, for sure, that is some boundary machine work with sheets. But if we're talking about a high volume project, it has to be roll to roll. And you can see, I think this is the beauty of print electronic. What we need to have is the paper, and then print, and then there is a product. It could be circuit, it could be antenna. You can see, yeah. And roll to roll has another reason. When we talk about medical application, there are a lot of screen printing process, also roll to roll. So I think this is, we see the potential of a paper in printed electronics. Yeah. Okay, I want to mention, because I emphasize our DOP is not only a product, also we have a quantified eco-friendly argument. We send our antenna to ISO and pass all these certification. One is heavy metal and toxic. In our antenna and paper, there is no heavy metal and toxic substance. And they analyze the material, no past the rules, and then our antenna is biodegradable. And then they put our antenna mixed with the compost, and it has to be disintegration after 180 days. And then the last is the aquosity test. It's a plant growth test. So I want to show you some very interesting tests. You can see our antenna will be mixed with 25% of our antenna and compost and soil. Another is 50-50. And the condition is all the soybean, all the soybean, they have to be growing as good as the control group. So it means our antenna, it doesn't affect the nature environment. If our product doesn't land it with a proper recycling disposable channel. So it means if something wrong, disposed in the environment, it won't happen. And all tests, after the test, they have a leaf, they have a flower, they have a seeds, and they will cut it, dry it, and make analyze. The result has to be, okay, the plant with our growing with our antenna has to be with the same result like the control group. It means if our antenna come in the nature and the plant, they won't absorb. And here's the certification. So ISO already tested. I think this is very important for the printed electronic community. So that is possible. We really provide something really, really good argument to a conventional etching process or other chemical process. And this is the final product. So we have this final product, and it's proved in this car, there is a chip inside, there is an antenna inside. And we get this approval, this certification. It means after use of our RFID product, you can put in the paper recycling bin in every office, in every hospital. You don't need to put it in the special hazy waste. And the potential for medical, okay, this is our product. It's a pilot round. So you can see if we want to integrate RFID and biosensor, okay, the old way is you have each antenna and you have a sensor. And in our project is we print everything on same substrate. Okay, this is the design. Okay, people talking about, okay, how about you make the smaller antenna, but the energy harvesting is with mobile phone. So we find this antenna size 50 millimeter times 50 millimeter is really good. So and then for this product we have a 7-layer. You can see that is NFC coil, insulation layer, bridge, and over there is a biosensor. Yeah. Okay, here. So totally it's 5-layer and 4 screen printing process and 1 enzyme dripping and 4 material with different curing condition. I think this is a real challenge. And in this example, we shall show it is possible to print such complicated design, and also the performance and the cost is reasonable. It's not label scale. It can be mass produced. Okay, in prototyping, just I show you, is by sheets, because sometimes we need to make different antenna design or circuit design. Yeah, you can see the thickness thickness of our antenna is about 14, yeah, micron. And most challenge is, you can see we need to put this complicated RFID CPU chip on that. And you can see there is totally 8 parts. And we need to, our antenna has to be fine enough to bond this chip, and it need to work properly. Okay, functionality, perfect. And you can see the left side. Okay, now the NFC phone via app, they make the setting through the chip, and then you drip the test through it, and you can see the beautiful curve, Yeah. So that is a very good solution. That is a distributed solution. Doesn't necessarily you have a meter. You just have a mobile phone, and you have this test drive. Yeah, and that is very, very good. Yeah. And a similar application, you can imagine, you are from medical industry, you can imagine there is a lot of medical sensor we can use our solution. Okay, and very important performance. And we make the comparison with conventional meter, and you can see the result is almost the same like meter. So I think we see great potential with printed electronic with our DOP solution, because which is very easy to produce, and we can print on paper, and the performance is the same like meters, yeah, like glucose stride meter. So I always use this slide to end my presentation. I think this is the beauty of a printed electronic. Without a chemical, very easy to handle. You have the paper and you print, and that is the product. Okay, yeah, that's my presentation. Thank you.
Thank you so much for this really fascinating achievement, and to have in the end a RFID antenna printed on paper and which can be put in the paper bin after its use is just amazing.
Yeah, may I
Thank you.
additional one sentence, okay? Because you mentioned about sustainability. All RFID antenna passed damping test for 1,000 hours. 85% humidity, 85 degree for 1,000 hours. And our product can immerse in water for 60 days and it still works. Yeah. So paper sounds fragile, but if you do it right, it's really good. Thank you. Thank you.
Even more remarkable. So thank you again for this outstanding achievement. And we will conclude this webinar with the first lecture to be given by Daniela from Fraunhofer. Daniela, it is your turn. Introduce yourself briefly and then go with the presentation. Thank you so much.
Thank you for the introduction. Can you see my slide?
Yes, we can. So just go ahead, adjust the
good.
full screen mode, and that would be, yes, perfect.
Okay, so thank you for the introduction. I will try to speed up a little bit because I think we're quite late on time. My name is Daniela Collin. I'm working at the Fraunhofer Institute for Silicate Research in Würzburg, quite in the center of Germany. I'm a chemist from my background. I'm working and leading a team for the material development of electronic and optical materials and applications, and we're centered in a center called CESMA, Center of Smart Materials and Adaptive Systems. And in that context, we're working with new materials, and sustainability evolved during the last years, and thus leading us to create a project and coordinating a project in this context, which Yves already told at the beginning. It's called Circle Paper, and in context of this EU project, I want to give a talk on printed circuit board based on paper and the challenges that have to be considered and the potential solutions which we want to create during this project. So much for the introduction. So why paper-based electronics? I think we heard a lot about this during the fascinating talks by Valerio and Alan. So our motivation was that the electronic waste strongly increases. We have targeted values for recovery and recycling of these electronic materials. And these values, which we want to achieve, are very high, but the situation is still so that globally and also in the European context, the collection rates are very, very low. And far behind the targets. And even if the recovery rate is increasing over the last years, the recycling is mainly focusing on gaining the precious metals. So this is only a small part of the electronic packaging, and we have a lot of substrate and components and stuff like that. And one main challenge here is that the conventionally mostly used PCB-based material is FR4, and this is very hard to recycle. So this is where we jumped on in the Circle Paper project and thought that paper might be a promising alternative to FR4. In parallel to all the other valuable works for electronics on paper, we wanted to focus on the recycling process and the recycling aspect of this paper electronic, because we think that paper recycling is a well-established process. The process in general might have to be and can be adapted to recover also electronic components and materials. And we hope for a high user acceptance, because the acceptance for paper recycling in a lot of European countries is very high. And so we think that could be an advantage. And which is in parallel and which meets a little bit with that what Alan just told us. Paper as a flexible material offer the possibility for roll-to-roll printing, which increases the throughput. So what's the status? There's a market for printed electronics, state of the art. We have smart packaging. We heard about the labels and also about roll-to-roll printed electronics. However, and this was a little bit also the background of this project, the highly integrated electronic circuits still difficult to realize on paper substrates. I think Valeria gave a very good overview of all the challenges which have to be met if you use paper as a substrate. So we also summarized all the technical challenges. So what has to be improved to realize conventional electronic circuits on paper substrates? So on the one side, we have the need for complex electronics, as I just said before. So there needs to be a high integration density. We should look for multi-layer boards and via technologies. And this has to be established if you want to create conventional and a broad applicability. And another technical challenge, we heard that before as well, is stability. So paper is sensitive against moisture and temperature deviations. And one main aspect which made FR4 so popular is the flame retardancy. So there we will have to catch up if you want to use paper substrates. And as we said before, this is one of the main focus in this project, recyclability. So everything we do to improve paper electronics must not significantly delay or reduce the recyclability of the paper or the other materials in general. So one aspect is water solubility of the paper substrate by adding any kind of additive. So we thought about the approach in our project. So we want to use the principles of circular economy in this technosphere compound. We want to use renewable resources, create functional bio-based materials, create the multi-layer PCB, which then can be given into the paper recycling process. So we want to also be using sustainable bio-based materials in this biosphere context, and materials which do not harm the environment, so they're safe by sustainability designs. So, and then when we have the paper recycling process, we want to regain the high volume paper material to recreate new PCBs, and on the other side also focus on usage of functional secondary raw materials. So not only focus on paper, but all the other materials as well. We also considered in these meetings with the other European project, what are the R's of the 10 R strategies of circular economies, which we want to tackle in this context. So we want to rethink electronics and improve the additive processes in this context, use hybrid techniques and galvanic processes if needed, create a good via technology for paper boards, and then also go into the aspect of recycling, as I said before, for the paper, but also for all the other materials, and then go into reuse, for example, the fibers, but also the components and metals, as well as polymers, so everything that has to be used. As we said, as already heard today, about the many layers we will have to create. I want to give a short outlook on the current status. So we still have 1 year left. So we're now in the final getting everything together kind of phase of the project. I want to focus on what have we done on the electronic paper, on the sustainable inks, on the galvanic processes. Is that possible on paper, and also on the multi-layer processing and vias, and all in the context of recycling and LCA. So concerning the development of the paper for PCBs, we're now in the stage that we can use 80% of recycled fibers for recreating new electronic paper. We found an impregnation material for the paper with sustainable additives to create a higher mechanical stability of the paper. You can see in the center of this slide the roll-to-roll application or impregnation of the paper. And with this impregnation, we not only increase the mechanical stability, but also the flame retardancy was increased. So you can see on the right side top the pure paper, and on the bottoms right side the flame retardancy test for a version of the impregnated paper, where you can see that the ignition of the paper is significantly retained. And as we demonstrated, at least here already, we have the possibility for the high throughput processes like roll-to-roll application for this electronic paper. Then we had a strong focus on developing new materials. So there was a bunch of materials, not only the conductive inks, but I want to focus on that in here. So if you think of printing conductive lines, you always think of silver, and our project partner here, we created silver ink, which is more sustainable. So from the silver source, we have in the final project ink, let's say it like that, which is ready for commercialization. They can use up to 80% of secondary raw materials, so there's a huge increase in sustainability here. And all the other additives like the polymer and also the solvents were adapted and are bio-based. And we created high chemical stability of the ink and of the printed lines. You can see it on the right for some demonstrators, and also a compatibility with the binder. And in parallel, we also checked other metals as an alternative to silver, which might come with a reduced performance maybe, but we want to check out if this can be a promising candidate. And we used zinc and tin, and created process containing mechanical sintering to increase the conductivity of this metals, which are prone to oxidation, of course. And what do we have to do if we want to achieve higher conductivity? Can we go on for galvanization? This was another big topic in our project, and which we worked on with our project partner at ICAP MMAB, which are currently also evaluating what can we do with our paper, with the pristine paper, but also with the impregnated paper, which you can see here with the brownish color. So we look for electroplating, for printing the seed layers, but also for copper lamination and etching to increase the feasibility if you think of conductivity in the later products. Finally, as I said before, to increase the density of all the components, we started to check up the multi-layer approach. We created double-sided demonstrators, as you can see on the right side. We found bio-based adhesives to laminate different sheets of paper. You can see it on the center of the slide. There are two printed papers glued together and aligned mechanically. And we also created a lot of we did a lot of work to create vertical interconnections and creating conductiveness through the paper. As you can see on the right side here, you can see again the yellowish color, which comes from the impregnation of the paper, and thus demonstrates the generation 2 electronic paper developed in this project. I think I will go through this very quickly. So we tried different drilling methods and achieved very good holes, hole qualities, and also the metallization was performed with different application methods, for example, dispensing or inkjet printing. And the conductivity through these holes was demonstrated to connect the different layers of the paper. Here, I'm almost at the end of the talk. I want to show you some examples of the preliminary work. So you can see a loudspeaker on the left side, which is folded, a loudspeaker with a double-sided paper on the bottom, and on the upper left, new versions of the impregnated and thus improved paper, which is also working through double layer application. And as I said before, our strong focus is on recycling. So we have partners who are very skilled in paper recycling, and they are looking at how good is our new paper. And this is mainly done now or in the next weeks and months, because the first focus of the project was creating the new materials, and now we are checking how good is it. So as I said before, we gain a lot of cellulosic fibers, but we are also very good and promising results in the recovery of silver, for example, and now checking also for the encapsulation materials, for example, components. And accompanied this is by life cycle analysis, which is now also evolving more and more because we now have the materials and all the data. So I think in the course of the next month, we will get more information about that, which can be shared. Yeah, so just to give you a short summary, we think that paper as an alternative has to be considered to tackle the e-waste problem. We think that alternative technologies have to have the same performance as conventional electronics in order to be used. And the printed assumption of this preparation can be assist to reduce the process costs and material consumption, and the paper recycling has to be further modified in order to recover all the materials. So I kind of speed up, and I hope that I kind of got everybody talking, listening and understanding, and I thank you for your attention at this point.
Thank you so much. So that was good because we gave more time for the presentation. No question arise, but what we said, the recording will be accessible in a couple of days. One more thing as well, the deck, the slide presented today by the three speakers will be also be accessible for anyone, the one having attended the webinar today and the one having registered, but for whatever reason were not able to join us. And I would say one question, or maybe for all of you during the last 2 minutes, what are the main takeaways, the main hopes, or the main message you want to communicate to the attenders about electronics printed on paper? Maybe we can start with you, Daniela, then Alan, and then Valerio. Very short, but key messages for the attendees.
Okay. So I try it very short. I think that the technology is very feasible. We have to find at any stage applications for that, even if you now not master the replacement of FR4 completely. I think it is interesting in many other fields, as Ellen already said, and we have to stay on the track and improve it, and in parallel look for application.
Alan?
Okay, I think from our experience, printed electronic on paper is there, technology is there and mature, but I think we need to find industry giant from first-tier company to endorse this technology. I think lacking of this first-tier company, we know that it's new, that's correct. People used different material for decades. It's really difficult to convert, but we see the change of e-vehicle within so many years. Within 5 years, every combustion engine maker say, oh, we have an e-vehicle solution. But 5 years ago, why they say no? Because they are not well prepared. When they prepare, they will say, this is a good solution. I see that's the same. We need to search strong support from first-year industry. Yeah.
Thank you so much. Valerio?
Yeah, I think we need support not only from end user, but we need support from legislation. I think legislative support on a technology that could be composted or it's very important. I think the next step, and it's in line with what Daniela was saying, is we need to, if we manage to improve and connect print electronic on paper with a more resource efficient recycling and recovering of material, that's where there is a win-win for this technology. Because you can, if you build up on the repulping and recycle and recovering and recycling of paper, and you can add to it recovery of micro components, metals, and so on, it's really a significant step ahead compared with plastic. So that's where I think could have a strong driving force.
Thank you so much, and even 2 or 3 steps ahead, the classical PCB technology. So thank you again for all those great lectures, and all attendees. Thank you for your attendance, and we will be in touch because additional information will be provided with once again the access of the recorded webinar and access also to the slide decks. Thank you again. Thank you.
Thank you.
Yeah.
Thank
Have a
you.
good
Bye-bye.
afternoon. Bye-bye.
Bye-bye.
Bye.
Bye-bye.